Hi, it's Robin.
Hi, this is Hag. Welcome to HAG'S Lab. The other day I was watching this video from Robin at 8-Bit Show and Tell. I love his channel. I recommend you subscribe to him, follow him, all that stuff. And you should also watch this video that I will link down in the comments before you continue to watch my video. It's not strictly needed, but I do recommend that you watch Robin's video. This video today is gonna be me trying out some stuff that I was thinking about while I was watching his video. And let's just quickly look at the intro to his video first so we know a bit what we're talking about here.
Hi, it's Robin. We haven't talked about my favorite 10 print programs since last year, so I think it's about time to take another look at it. I'm talking about this one-line basic program that I find so interesting. When you run it, you get a maze.
The video got me thinking about a few things, and I really liked when he tried to use different sources of randomness to create this maze. And I know that if I use my C64 emulator that I made myself, I'm gonna have some issues with the randomness. So let's just try some random stuff and see what happens. So as I said, I'm not going to go into the optimization part that much, but there was one interesting thing here when he changes the RND1 to a dot.
The 1 to a dot and get rid of the line.
I'm not quite sure what the optimization part is right there, but I was wondering what this random function actually does. So I was having a look at the documentation for random in C64 Wiki. What it says is that if you're using RND with a positive number, you get a different number each time from a predetermined sequence. The sequence number is stored internally. So that's fine. If I just take Robin's optimized code, except that I'm still using RND1 here, I'm gonna paste that into my emulator. There we go, and that should give us the maze as expected. But now if I change that to RND dot, now this is what got me onto this, and this is why I'm looking up the documentation, because when I do this in my emulator, let's do run, we can see that I have an issue. From an optimization standpoint, that's like 1 and dot is not the same thing. Anyway, that's when I started to look at the documentation, and it says if you use RND 0, the C64 generates the random number from the internal clock, though the possible values are limited as the digits of the clock only fall in the range 0 to 60. And that makes sense, right? So let's do print. I'll do 0, 0, print 1, 1, print RND 1, gives us a random number. As expected. Now if I do that in my emulator, let's do print RND 1, it's a random number. Yeah, gives me random numbers like I expect. Now if I do print RND 0, I get something else. It's not correct. And that's gonna be the same for me if I do print RND dot. Let's have a look at that again in Vice. So I do print RND, print RND dot. You can see that behaves correctly here. And that does make sense to me because I know that my CIA implementation, the CIA implementation is not complete. I'm still implementing that chip in my C64 emulator. And I know it's the implementation I have is buggy, and I know that, so that does make sense. So that's the first interesting part for me. I know that this is going to fail when I do R&D 1. I mean R&D dot. So let me just try and put that in to my emulator. So you can see that I have this issue. So this is my emulator running in Visual Studio. I'm in debug mode right now. And if I paste that line again, I'll do Ctrl+2 to get white. And when I press run here, if you take a look down in the immediate window here, we're going to see some debug messages. There we go. So we can see that the CIA register is not implemented, and it's looking at DC04, and DC is actually looking at 4, 5, and 8. 4, 5, and 8. So the R&D function is reading from DC04, 5, and 8. And as we can see, that is the timer A current timer value. And it's also using the time of day 10th of second, which gives a value of 0 through 9. So anyway, it's using these registers in the CIA chip. And since that's not implemented correctly in my emulator, it's not going to work. So that makes sense. So R&D 0 and R&D dot, which is the same, is using the CIA registers to get the random value. And if we try that same code in Vice, let's just paste that in here, we can see that it's working in Vice correctly, as it would in a real C64, as Robin is showing. This is one of the interesting parts in Robin's video. This is his assembly program that uses the SID as a source of randomness. He's using the noise waveform channel of the SID. So he's taking the random value from D41B, which is the oscillator, the noise oscillator in the SID. So we can look at D41B in the memory map if you want. D41B. That is the voice 3 waveform output. I've also implemented this program in assembly. I have it right here. It's the same thing. I also set the text color to white just to make it easier to see on screen and so that I don't have to do manually. It's the same initialization code for the SIDs, and the loop is also the same. Now let me compile this and try and load that up in my emulator. So this is ML1 assembly SIDs. And we can see that I have the same kind of issue here as I had with the CIA, using the CIA registers. And again, that is because I have not implemented the SID in my emulator. So it'll always get the same value, which is going to be 0 in my case. And if we try the same thing in Vice again, we can see that the program works fine, as in Robin's demonstration. And also the randomness looks pretty decent. This could easily pass off as true randomness, even though I don't think it is true randomness, but it's pretty close. So for my testing, I decided to write some programs in C as well. So if you take a look at this one, it's the same as the assembly program taking the randomness from the SID. It's just written in C. I'm using the CC65 compiler to compile it into a PRG file. I have some defines for the SID registers here. And then we have the same SID initialization code as in the assembly. And then I just loop forever and take a byte of randomness from the SID voice 3, and I'm printing that to the screen. I'm using printf, and I'm just taking the random value from the SID, ending it with 1 and adding 205. So let's have a look at that in Vice. So that's this program right here. Should give us the same thing as Robin, and the assembly program I just showed. It's just very much slower since the assembly program runs faster, of course. I wanted to have a better way at looking at the randomness of the random source than just looking at the maze. So I decided to make one more program, which is this one right here, SID checker. It's called checker because it prints a checkerboard using the random values. So let's just compile this program and I'll show how it looks first. We'll open it in Vice and we'll take ML1 SID checker. There we go. So we get a nice like static image kinda, and every time I press or hold enter, it's gonna update. So when we look at this, it's actually looking pretty good. It's looking random to me. I haven't been able to find any repeating patterns. But as we know, I have the issue in my emulator that if I try to open this, I only get a black screen. This program basically fills the screen with reversed space characters, and that's just an easy way for me to set different colors to the characters to make a checker pattern. And then I have this function that gives me a random byte from the SID output. And fill checkerboard just goes through every cell of the screen, well actually the color RAM, and it takes a random byte from the SID and ANDs it with a 1 and sets either white or black to the color of the cell. We'll come back to this KB repeat call afterwards. We set the same SID registers as before. We fill the spaces, or fill the screen with the spaces, and then in an infinite loop we fill the color RAM with the checkerboard pattern, and we wait for a keyboard input. And that's where the KB repeat thing comes in, because if I hold a key down, it will continuously run the for loop for me, so I don't have to press the button multiple times. I don't think I will be implementing the SID in my emulator anytime soon, but I do want to see the same kind of effect in my emulator, so we're going to cheat. And I'm looking at my C64 bus implementation right here, and I have made some code ready. This here is what handles the SID part of the memory. So you can find the SID between D400 and D700FF. When we look at this program again, we can see that the voice 3 output is at D41B. So we're just going to cheat, and we're going to say that if the address is D41B, we're going to return a random number between 0 and 255. This is non-inclusive. So if I run my emulator now, and I open the same program, the SID checker, we actually get some noise there. And this is obviously cheating, but we're just playing around there. And if I hold this down, it's still very random. And this should be a very good randomness source, because this is a cryptographic randomness API we're using here. We can now go back and have a look at the assembly program that takes the randomness from the SID, and that works fine. And we can also test the C version, and they both look okay now.
And loading a byte from the kernel ROM F002 indexed by X, that is, the value of X is added to it. So I put random in quotes because this is very, very not random. It's just a 256 byte sequence of numbers.
So that's pretty interesting as well. So Robin, he made a script to search through the kernel ROM to find the most random sequence of numbers. And the way he did that was like he was looking for numbers that were giving 50-50-0-1. At least the distribution is fine. So it's 50-50 distribution between ones and zeros. But it's still a repeating pattern. So it's not random, as Robin explains, but it's actually, it works as a decent source of kind of pseudo randomness, I guess. I implemented this in assembly as well. Well, I just copied Robin's program. I've added the set white text color part, and we can compile this. I'll open that in my emulator. So this is ML3 ASM ROM. And as we see, it's actually looking quite okay. If I hold down Control, we can see it a little bit slower. It is possible to see the repeating pattern here. So if you take a look at this, we can see the repeating patterns. You can see this part right here. That is repeated there. And we can also have a look at these 3 diamonds here. They are repeated over there and there. And to make this more apparent, I have my checker program as well. So let me open that, ML3 ROM checker. And this makes it a little bit more clear, because you can see, if you look at this square here with these tabs on it, like 1, 2, 3, and then you have the one under, you can see that over here, and you can see a new one starting there. So it's definitely repeating. So if I open ML3 ROM checker, I actually have this line here that if I activate it, now if I open that, I'm changing the colors after the full sequence. So every time the colors change, the sequence restarts. And we can clearly see that it's the same sequence every time. So if we look at the start now, every time it's a 1, 0, 0, 0, 1. And it's the same part there, and it's the same part there, and the same part there. This one is also interesting. Here Robin is using the D012 raster register. We can actually look at D012. This is the current raster line. Again, I have some code for that. I only have C code this time. We do all the same stuff as earlier. We just get our random byte from the raster line register, and everything else is the same. Let us compile this and open raster checker, and we can see that that doesn't look very random at all. And if I press and hold return, we can see that although there's a decent distribution of zeros and ones, it's looking kind of the same the whole time. Still looks pretty decent as a maze, and it definitely serves as a good enough randomness source for this purpose. So even if this is not that easy to detect in the maze sample, it's easier to see in this checker kind of view.
So we'll load in ML5, and instead of the raster interrupt, we're going to be reading from the CIA timer A low byte. This is the timer that's continually running until you tell it to stop.
We read the CIA timer A low, we end it with a 1 to get a 1 or a 0, and then we add 205. So it's the same as everything else. It's just a different source. And we can see that I still have this issue that I showed you in the beginning with just the basic version. And that's because my timer is not counting as it should. Luckily, I have made a fix for that as well. So as you can see, this is my C64 bus again, and this is where the CIA1 register is read from. It's the range from D000 to D000FF, and DC04 is still a low timer value. And you can see that I have a new random source I've named random 0, and I just get a byte from there every time this timer register is read. So with this new fake randomness source R0, we should be able to see some kind of randomness from my CIA as well. So let's just start by doing this one, and well, it does look somewhat better, but it doesn't look very random. Seems to be definitely repeating. We can see that here. Does it gonna come back at some point? There we go. And it's always starting with the same on the left and the right side. So that's also strange. So let me try the checker version. This doesn't look very random at all. This looks like a QR code. So maybe you should check that out before you continue. Just pause the video, take up your phone, have a look at the QR code, see what happens. So hopefully you checked out that QR code now, and I'm sorry, but I had to do it. But I have more random sources there. So let's go to R1 and let's see what kind of randomness source this is. Let's do the maze first. Doesn't look very random. We have some stuff in the middle there. Doesn't look very evenly distributed. Does barely any change. Let's try the checker pattern. Okay, so hopefully if you did scan that previous QR code in the R0 source, you will hopefully recognize the dancing monochrome silhouette of Rick Astley, and you've just been rickrolled twice. Hopefully. I did have to speed up the emulator a little bit to get this animation at a decent speed, as you can see. So ramping it up to like 3x, it's not too bad. Well, I have one more source. That's going to be R2. Let's see what kind of randomness this is. Let's do the maze. Doesn't look like it's working at all. Oh, we do have something. Okay, let's just go to the checker one. Please subscribe. I'll see you next time. Bye.